Hello everybody, we will continue lessons Properties of Probability and Relative Frequency Approximation, Lecture 3. Here's the lesson plan for today. Properties of probability of an event, equally likely events, notice for combinations, and relative frequency approximation. Properties of probability of an event. Probability of a certain event, which is equals to 1. Probability of a certain event, P of A equals to M over N, or which is N over N equals to 1. So this is the lecture 3. It's the certain event. Probability of an impossible event equals to 0. Probability of an impossible event equals to 0. For example, when you flip the coin will stand on the edge. So this is almost impossible event, so we calculate its probability as 0. Probability of an event is positive, event A. Of an event A is positive and between 0 and 1. So probability of event A is between 0 and 1. Sometimes it can be equal to 0 or 1. Equally likely outcomes. Outcomes are considered as equally likely and should make sample space. We've talked about sample space in lecture 1. We consider in the formula n elements as different from each other. If we have to put some elements as repeating order, we call them combination with repetition. For example, there are n elements consisting n1 of first element, n2 of second element, and etc. Then we can calculate permutation with following formula. So if you remember, we had permutation formula like this: Pn equals to n factorial, which is 1 times 2 times 3 times 4 and etc. till the number n. But in this case we have to write Pn and 1 and 2 and etc. So we want to calculate the permutation of n elements consisting n1 of first and 2 of second and other. If we calculate the sum of these elements, they should make number n. With rules. Here's the sum rule for simple probability. If some object A can be chosen with m ways and another object B can be chosen with n ways, we have to choose A or B. We can do this in m plus n ways. And the product rule for simple probability: if some object A can be chosen with m ways and after A another object B can be chosen with n ways, we have to choose AB. We can do this in mn ways. So for example, you want to buy an ice cream. First of all, you have to decide which kind of ice cream cone you want to choose and what type of ice cream. In the shop which you are looking for ice cream, there are 3 types of ice cream. First of all, with fruit, like the second one was chocolate, and the third one was nuts. 3 types of ice creams and 2 types of ice cream cones. 2 types of ice cream cones, like this one and this one. 2 types of ice cream cones and 3 types of ice creams. Here we have to use the product rule for simple probability. Either first of all you will choose like fruits. How many types of ice cream we have? M equals to 3. How many types of ice cream cones? N equals to 2. So the ways we can choose this, like m times n, which is 3 times 2 becomes 6. How to know? If you want to choose the ice cream with fruit, you have to choose either this cone or this cone, or chocolate. In this case also you have to choose this cone or this cone, or with nuts the same, this cone or this one. So you have 6 ways to choose ice cream. This is according to the product rule for simple probability. Observed or statistical. We've talked about observed or statistical and relative frequency approximation in the previous lecture also. So we have to know the number of times A occurred, and we have to divide this number of times the procedure was repeated. Here are some questions. A man wants to call to his friend. He forgot the last digit of the phone number. What is the probability that he can call to his friend in the first trial? Which is P of A equals to M over N, 1 over 10. He forgot the last digit. How many digits we have? We have 10 digits starting from 0, 1, 2, and till the 9. So we have 10 digits. He forgot just one digit. So the correct one is any of them. So one of them correct. Total number of digits 10, 1 over 10. This is the probability he can call to his friend from the first trial. How about if he forgot last 2 digits? We have 100 numbers or digit combinations for last 2 numbers of phone number, but one of them correct. So the probability that he can call from the first trial is 1 over 100, which is also equivalent to write 0.01. His next exercise. In the box there are 10 boards, 7 of them standard boards. What is the probability if we select 6 boards, which will get 4 standard boards in this trial? So it says in the box there are 10 boards. There is a box, this kind of, and there are boards, small details, and there are 10 boards, 7 of them standard. I want to choose 6 of them, and I want to know what is the probability between them. 4 of them will be standard. All possible ways we can choose 6 boards out of 10 can be calculated using combinations, which is 210 ways, and all possible ways we can choose 4 boards out of 7 standards is 35, and all possible ways we can choose 2 boards out of 3, which is non-standard boards. There are 3 ways, and the probability can be calculated using this formula. This is in the probability formula M. This is N. Total ways, total number of ways we can choose the boards from the box. These are the ways that we can get 4 standard boards and 3 non-standard boards. So the probability that we'll get 4 standard and 3 non-standard boards when we choose 6 boards from the box, it's 1 over 2. His next exercise. There are 50 balls in a box, where 5 of them red. What is the probability that randomly selected ball will be red? We want to select just one ball. So I want to know if it's red. So how many red balls do I have? 5. Out of how many? 50. So the probability of event A is this one, which is 1 over 10, can be written like 0.1. So his next exercise says, what is the probability of getting even number on top of a die when it's rolled once? We show this example in the previous lecture also, previous page also. So when we choose even number, when we roll the die and getting even number, is there are 3 even numbers, 2, 4, and 6, but total number of outcomes 6. 3 over 6 gives us 0.5. There are 5 cubes in the box, 6 sides of each cube painted with 1 letter. Following letters O, P, R, S, T, find the probability that when cubes taken and put it in a line, what spot can be read. This is the arrangement that we can calculate the word spot appearing from these letters when we choose from the cube. Arrangement of 4 letters out of 6. And we have to divide 1 by that letter in order to get, no, sorry, there are 5 cubes in the box and 6 sides. No, it's not correct written here. We have to calculate 5 cubes of permutation. Here, permutation of 5 cubes. Permutation, which is, let's say this is 5 factorials equals to, so in the first can be one of the any number, and the second we need order is important here. So 5 factorial, 1 times 2 times 3, 4, 5, 2, 6, 24, 120. So it will be 1 over P5 equals to 1 over 120. So this is the probability of getting the word sport when you extract cubes from the box. 8 different books placed in a bookshelf. Find the probability that 2 books will be placed side by side. There are 8 different books placed in a bookshelf. So how many ways we have to put them in a bookshelf? It is 8 factorials, and it's important that 2 books will be placed side by side. Let's say we have different books here, like 4 and 5 and 6 and 7 and the 8th number. Let us say this is history, this is English book, this is Russian language, and the mathematics, physics, chemistry, and let's say programming, and also electricity book about electronics. So we want to know that the book mathematics and physics put it together side by side. So how many ways we can arrange these 2 books together? We have 2 ways. In the first place can be one of these 2 books, and in the second place one of another one, so which is 2 factorial. And how many ways we can put our remaining books? How many books remaining here? 1, 2, 3. 1, 2, 3. 6 books. It's also 6 factorials. We have 6 books and 2 books joined, like we want to know that they should stay together. Let's think them as a joined book, so we also have to multiply by 7, because here we have that the 6 books here, and we consider this as a 1 book, so totally like we'll have 7 books. The probability can be calculated using above formula, which is 1 over 4. Good luck guys, see you in next lectures.